All right. Kia tato katoa, ko Carolyn Lundquist tako ingoa. I'm Carolyn. I'm from NIWA in Kirikiriroa, as well as an associate professor at the University of Auckland in the School of Environment. And thank you, Debbie and Lucy, for giving me the opportunity today to talk about how do we actually bring climate change into marine spatial planning. So a lot of people in the room will have been aware that there are quite a few different marine spatial planning exercises going on around the country, as well as within New Zealand's international commitments. And so this is, can we actually future-proof MPA design? Of course, we do need to move forward with our marine protected area design and what we are moving forward in the future along with that. But what types of tools do we have, and how do we bring climate change and climate change resilience into these types of tools? I like putting a few pretty pictures, but there's our lovely Aotearoa focused world, and that blob in the middle of us is Aotearoa in our EEZ exclusive economic zone. About 400 million kilometers squared of the oceans is something that New Zealand manages. And because we have this huge latitudinal range, so we go from subtropical to subantarctic, but we also have this huge depth range. And that means all these different animals and plants that we have living in the ocean are subject to a wide range of potential impacts of climate change. Whether, for example, a lot of our deep sea coral taxa are subject to changing in the aragonite saturation depth, so an ocean acidification impact, or our coastal animals that might be subject to more intense storms due to climate change that are changing the amount of sediment coming in from the coast into our nearshore oceans and estuaries. So there are many, many different ways that climate change impacts on our species. And so how do we bring those types of impacts into designing for marine management that's resilient to this future change? And of course, there's a few of my pictures. I should have put this one up a second ago. So we do have some of our deep sea corals, but we also have some particular beasties. One of my favorites is our New Zealand mangrove up on the top right there. We do quite a bit of work on looking at blue carbon in these habitats. And people down south don't know that mangroves are increasing at about a rate of 3 or 4% a year in New Zealand. So we do have some of our habitats that are doing quite well with sediments and potentially also with climate change, but also are potentially very good reservoirs of carbon. So these are all different things we can bring into our planning. So how do we both protect species, but also protect the things that are actually a joint biodiversity and climate change mitigation strategy? That might be, oh, that's one more slide. When I put that one up, I threw up my IPCC Ipis from Friday's report slide. But this actual picture here is one out of one of the things I'm involved in with Ipis. So Ipis is this international science policy platform, one of the UN platforms on biodiversity and ecosystem services. And I thought it was quite interesting listening to the debate just a minute ago on what is our role as scientists, and potentially I flip a bit more into the advocacy, but I use my role as a scientist to make sure that we have the tools available to actually tackle a lot of these hard questions of where do we go next. And so one of the things that we're working on is developing tools that help us come up with what these future scenarios could be, and how do we bring all the different pieces of the picture into it so that we have tools for our governors, for our Kamatua, and for helping inform what decisions they make. But going a bit more into that, what tools do we actually need to help people make these decisions, rather than just going, here's a bunch of data, do with it you please. Well, we can take the data, we can actually populate the data into ways that people can use that to make informed decisions about futures and future states. And this is just one particular set of future imagining that we have for the oceans, where we're looking at different ways that we value nature. So this one is more intrinsic values of nature, but we can also value nature for ecosystem services, for the societal or economic gains that we get from nature, for water filtration, or coastal protection, things like that. But we can also imagine ocean futures that are very much around our customary management and our relationships with the ocean. So I think in terms of things that we're considering as we do marine spatial planning, we're not just protecting the ocean for ocean's sake or the ocean for making sure it's supporting fisheries, but we're also making sure that we're protecting the ocean for the relationships that we have with the ocean, for those spiritual and cultural practices, and how we all have this sense of place based on being a New Zealander and experiencing the ocean. Anyway, that was just my little Ipis blurb, but we do need to figure out then how do we actually bring these types of knowledges and processes in to come up with ways to predict and manage the ocean within the face of a different changing climate. And how do we understand how that changing climate influences the values that we have and the socioecological ecosystems that we're trying to protect and conserve for the future. Many of you have probably heard of ecosystem-based management. So this is one of the kind of key things that the Sustainable Seas National Science Challenge is based on. And if you look across ecosystem-based management, it's moving away from that single sector fisheries management that we typically did 20, 30 years ago in New Zealand towards something where we're basically bringing together that multitude of uses and values, biodiversity being one of them, but a number of competing space things, but also bringing together that resilience, or how do we make sure the system and how all of us have different views of what that system might be and what values of the future that we hold most strong, but how do we make sure that that system is resilient to climate change? Here's I put this in the wrong order. I put this one in, but you can see this is this report that came out from a UN joint thing. And this workshop was actually quite interesting because it's quite unusual in the UN world. I suspect probably similar to how we work in New Zealand, where we very rarely have days like this where we have Department of Conservation, MPI, Kaumātua, NIWA, universities, and everyone all together in the same room talking about a new issue. This was actually a first for the UN where they had these two major global bodies meeting together, Ipis and IPCC, saying, how do we actually work together to have some global assessments that are doing both biodiversity and climate change management. So, but they've got their little circles that are merging those two together. So I think there's huge hope for the future that we're actually going to get somewhere in bringing these two types of things or types of major global scientific bodies together. So back to spatial planning. So spatial planning, we've done heaps of this in New Zealand. I know we've currently got a lot of work going into the South Pacific High Seas. So looking at how do we use spatial management to minimize the impacts of fishing on deep sea vulnerable marine ecosystems. It was used to inform the Harkey Gulf Marine Spatial Plan, Taitimu Tapari up in the Sea Change Plan. Been used in the Chatham Rock Phosphate Consent application to identify mitigation zones to protect particular benthic invertebrates, and many, many more. So we're seeing added ways where we now have all this wonderful spatial knowledge. So we have data layers, whether it's of species layers or habitats or other information, and we can bring that together along with threats, for example, different threat layers coming from potential changes in climate. We can bring those all together to come up with best places for a particular use, or quite often in what we're doing is looking at marine protected area or benthic protected area zones. How does this normally work? We take a whole bunch of layers. So we're quite fond of bringing a lot of layers like our protected coral layers. I'll show a few of those. But we have right now from some funding from the Department of Conservation, we have and Ministry for Primary Industries, we have 613 individual species or genera that are modeled for the entirety of the New Zealand EEZ, though some are only down to about 2,500 meters. So there's a lot of information out there now. We also have lots of great understanding of where the different resources. So we know where, for example, this particular layer up on the top right is a fishing layer. We can take all of those bits and pieces and put them together and come up with an optimal trade-off model. So where is the best place where you can still, as we call it, have your fish and eat it too. So we want both biodiversity, but we also want to be protecting our industries that are a very big part of New Zealand as well. And so those come together, you get some type of modeled solution, And then that's just one piece within a stakeholder participatory process. So there's a whole bunch of other things that go on where people look at pictures on a map, say that's not going to work, but move it 3 inches to the right. And a whole bunch of things go like that. Different values are brought in, et cetera, as many people might know from the Harkey Gulf Marine Spatial Plan and the iterations going on right now. And you end up with some type of plan that's ended up approved by government. I think SEMP is another one that's up there right now, the Southeast Marine Protected Area Forum. So lots of these types of planning processes, and they go through that information gathering through to spatial mapping, through to decision-making process. So where does climate change come in there, and what can we do in terms of bringing climate change in? Well, I thought I'd come up kind of 3 different ways that we're currently using climate change in these models. The first comes from some work through Sustainable Seas based on some layers funded by DOC, and this is a joint collaboration between 2 of the Sustainable Seas, one of the cumulative effects projects and one of the risk and uncertainty projects. And it's basically, can we take some models that we have? These are protected coral species. So all of the protected corals are listed under the Wildlife Act. So we do have a role in New Zealand where we do have to provide protection for these species under legislation. But taking some early models that were done, not that early, published in about 2016, and expanding that using some outputs from the Deep Sea National Science Challenge. So that's the kind of New Zealand iteration of the Earth Systems model. So big fancy global model, tells you what all the currents and waves and temperatures and all of that will do, probably exaggerating a bit much if anybody's in the audience, but basically a cool model that gives predictions into future states. I think there's a 2050 or a 2090, something like that. And so we can then take all of these drivers of where species might be and say, this is where the models tell us, if we add up how a species responds to temperature, to waves, to winds, to sediments, and this is what temperature, waves, winds, and sediments are going to be in 2050, we think, according to these models, under a particular climate scenario, then we can have a new map of where we think that particular animal might be. So the first kind of simplest conceptually, I think, approach is basically making new models of where these species are. So we've got 613 now. We have, I'm going to look at Fabrice, 10, 11. How many are in the 10? And we have 10 where we have these protected corals, where we have the current, as well as we have a kind of future optimistic and a future pessimistic version. So we can take those, and here's just an example of one of them. This is Goniacarella demosa, one of our deep sea corals that we like to model because there are lots of great data. I think all the little red blips on the left plot are where we actually have point records of these species that are used to model it. And then I take these layers and I put them in zonation and do my magic and say, well, if that top scenario, sorry, these pictures are pretty ugly, I made them myself. The top picture is our version of the current prediction. All the red bits are basically where the model says these are the most important places to protect for deep sea corals. But what's interesting is looking at the middle plot is our optimistic and the lower plot is our pessimistic scenario under future climate change. And the question is, what has changed between those? Which ones do we, how does that change where we want to make sure we're looking at protected corals, particularly for refuge areas? And again, people are taking these pictures. This is work in progress, just to be clear on that. We're still working on this project, but looking at why do we have these changes going on? Are they changes in a particular environmental variable? For example, these models do have the aragonite saturation depth in there, so we would expect deep sea corals to be responding quite strongly to that change in depth on where they might dissolve, but also temperature preferences and things like that. So we're at the point where we've got the initial models, and then we're doing a bit of looking into them to see exactly what the key drivers are, but also some of the stuff that Fabrice Stevenson is doing is then looking at how are changes in our fish distributions going to change the potential co-occurring threats. So will fishing be likely to be in different places than we have our deep sea corals, and how is that change and overlap going to be? So this is basically one different type of modeling we can do. And there, as any modeling, there are a lot of caveats in this one. I think one of the things, what I've put down here is comparing our 2016 and our 2020 models for one species. And the environmental predictors that we used in 2016 are actually quite different from the ones that are available in the Earth systems model. Their systems model has these big global predictors. The 2016 one had a bunch of awesome national layers that we have on sediments and chlorophyll and things like that. So how does changing environmental predictors change things? Do we actually have any certainty in what those environmental predictors are going to be in the future? You know, are we completely making stuff up on these 2050? I know somebody talked about this earlier this morning. Do we really have any idea? Can we predict out 10 years, or probably is 50 years a bit too much? So having that, recognizing that uncertainty and being able to communicate that to people that have to make decisions. But also we have lots of different ways of modeling species. So we can model on a spectrum from habitat suitability all the way through to predicting species abundance. That depends on how many point records you have. So if you've got 20 point records, you're kind of making stuff up, not quite, but we usually go quite a bit higher than that before we feel confident in the model. And then different models have different predictive ability. We'll have an uncertainty layer that goes along with them, but lots of great advances that have been going on in what we're able to do, certainly in the last 2 or 3, 5 years, in what we can do, which is fantastic. And then I just put that one up. That's just an example of the uncertainty in the habitat layers themselves. So the one on the left would be a predictive model of where we think a particular coral is within the EEZ, and the layer or the picture on the right, all the red spots are places where we really have no idea, and we have just about as much uncertainty in the model as we are predicting that something might be there. So just all those things that we need to recognize when we're bringing layers in. So I came up with a couple other ways that we are currently using. So within one of the other sustainable cities projects, or one of the same ones I just talked about, I call it SpecSet because it's much shorter than saying spatially explicit cumulative effects tools. I can get that out in one breath. But this is another work in progress where rather than taking these predictive models, we're actually trying to just bring the stressor layers in. So we're assuming we have a pretty good idea of where a particular species or habitat is. So for example, I could map out where mangroves are now, and then I could take different stressor layers on temperature or sediments or ocean acidification, and I would know what the biological responses of that species are, and then bring those together to then predict the future of that layer. So this is something, again, we're working on. So it's bringing kind of a decrease in condition of the species within this zonation, this kind of decision-making tool where we have a layer, and if, again, it was a deep sea coral layer, we could overlay that with our aragonite saturation depth. That's the more bluey picture on the top right. So the places where that will be going down, we know that it's going to be less valuable for protected corals. So we could assume then these are much less likely to be a good refuge habitat and a good place for protected corals. So those are kind of our two good mathematical approaches. And this is just kind of one little picture of some early work that Tom Bro, who works at NIWA, has been doing on this project. So basically bringing the stressor interactions, and this picture is kind of a plus minus picture. So that if it's red, it means that we're more likely to have, or that it's more suitable than it was under the current to the future state, and the blue areas are places that it's less suitable, but bringing the stressor interactions into these models to say what places are more or less likely to have that particular species there. Then we bring it all and make those pretty pictures again in zonation. So we've again got the same type of approach of spatial planning, but bringing it slightly differently how we bring climate change and different stressors in. I'm nearly done. Anyway, I think going back to this was, I'll call it option 3, but I'll call this best practice MPA design in general. But I was thinking to myself, well, what do we really do normally? What do we tell ourselves that we need to do in marine protected area design? Well, we need to have size and spacing that's appropriate to protect the particular species and habitats that are within our objectives. We want bioregional representation. That's something that ensures we will be protecting current and future ranges. So if things are moving south, I love all the snappers showing up in Dunedin and other things, but if things are moving south, we want to make sure that we actually we're not just protecting species. For example, right now, the majority of our protected areas are in the Kermadec and the subantarctics, but very little in the middle. So how do we make sure that we're covering that range of areas and have that bioregional representation of marine protected areas? Replication is insurance for unexpected events. And again, not just replication in one location, but replication throughout that range, so that if we do have an event, for example, a summer heat wave might come in and have a major effect on some stocks. So making sure that we do have enough replication of protection in different areas that are likely to be outside of that influence of that particular extreme event. Understanding and maintaining connectivity. I've got a very generic picture on the top right there of the main circulation around New Zealand, but making sure we know what might change. Are we going to get changes in our circulation? In the Moana project, there's a big MB Endeavour fund that's looking at changes in circulation. Are we going to have big changes in productivity over the subtropical front? That's particularly important, lots of things like that, but understanding connectivity, changes in productivity, changes in resilience, and of course that bottom one. What's the biggest importance about climate change resilience? It's making sure we're not throwing a whole bunch of other things at our ecosystem. So how are we making sure that we're not throwing pollutants and sediments, that we're minimizing the impacts of fisheries and other benthic disturbances, but by basically keeping our ecosystems healthy, that they'll be more resilient to climate change. So I will end with that. And thanking all of the many colleagues that have been involved in probably 30 projects that were in this talk.
We've got time for a few quick questions if anyone would like to.
Catherine.
Excuse me, Catherine Short from Terra Moana, long-term ex-WWF. Thanks everybody for the day today, really exciting, and Carolyn for this talk. It was neat to sit through this material in detail in the recent MPI Science Working Group, and thank you very much for this fantastic work. I'm a little concerned about the language of best practice MPA design when I haven't picked up any references yet to a whole mātauranga work stream included there. Appreciate the design of the projects was a number of years ago, and it's now a hell of a lot more currency in that dynamic now in Aotearoa, which is terrific. Can you perhaps comment on opportunities for bringing mātauranga into it, in the next era, rather than I'm not actually criticising the lack of it in the designs so far? Thanks.
And I think, I suspect someone from DOC is probably more placed, Debbie, if you want to break in here after I say something, but certainly within, I think I had a slide that I took out that I should have left in, that's kind of how the process works and where different information streams feed in. But within the tools that we have, and certainly within the Sustainable Seas project that we've got, we do actually have 3 different work streams. We've got a national case study that's this very kind of offshore case study that's far less, not mātauranga relevant, but less directly mātauranga relevant. But we also do have a Hawke's Bay, as well as a kind of Rohe Moana case study in Ohiwa, and both of those are directly bringing mātauranga into the spatial planning context. So within this context, I'm sorry I didn't talk about any of that today, but certainly these types of tools can bring that in. And within spatial planning, I think a lot of it depends on what objective we're given to bring in. And I know within a lot of the work we've been doing with DOC and MPI and others, it's seen as something that they definitely to figure out what is the process of incorporating mātauranga, what stage mātauranga comes in, how they make a fair and equal process for that to come in, rather than being an aside that comes in at the end. And I think that's all, I think, potentially part of the processes that, again, are outside of my expertise in decision making. But yeah. Debbie? she's going, no, or Amelia's here as well.
Kia ora koutou, tēnā koe, te whaia mō tō karakia mō tō mihi mahana ki a koutou. Nō reira, tēnā rā koutou. Ko waio, ko Nicola McDonald Aho. I'm the co-chair of the Hauraki Golf Forum and a couple of other hats as well. But thank you. I really appreciated your presentation and I really enjoyed your last answer to the question. It was a really good partai actually. I guess one of the things that I've observed is that and maybe that's because you're all scientists. I'm in a room full of scientists, and you all use the correct terminology of mātauranga Māori, which is really good. There's something else that really comes before mātauranga Māori, and you almost touched on it in your presentation, and that's tikanga Māori. And I'd really encourage to see how you include rāhui tapu. How do you include taipuri, mahinga kai? Those are all customary management tools that we should be exploring around how to restore and protect marine protected areas. And you kind of did sort of touch on that. So, you know, thumbs up for that. Also, it takes a whole of sector approach to deal with the issue, and fisheries industries are one of them. But let's not forget urban development. Let's not forget the role of councils, the way in which they apply and manage resource consents, the increasing of sedimentation and pollution. And, you know, and as I say, I thought that it was a really good presentation. I enjoyed the graphs that you had, and I'd really like to say, Carolyn, bring some customary knowledge, some tikanga into your kōrero, and you're spot on for me. So kia ora, thank you.
Kia ora. Yeah, I cannot agree more. I'll just say yes, definitely.
Please ask, thank you very much, Carolyn. That's fantastic. Can I please